We are picking up in lesson 7.6 where we left off on Friday. And if you recall, we are learning about natural logarithms. What base are natural logarithms? Base E, right? That magical natural number on the calculator. Base E. So at the top of the page, we had used our product, quotient, power, and identity properties. Mostly product, quotient, and power to combine logs. And then on this part of the page, we were solving equations. And what phrase we were using to solve these equations? Left, right, middle. Okay, so let's just kind of review and look at example D. And then we'll move to the back side. Thoughts on how to start D? Kendra? Okay. Yeah. You have to watch out here. We can't jump straight into left, right, middle. Because in order to jump straight into left, right, middle, it would have to be a log equaling to something else, equaling to a number or a value. And at this point, we have 2 times a log. So what do we do with that 2? Move it to the power. And so this is going to be the natural log of 6x plus 1 quantity squared still equals 3. Okay, now what? We have a log equal to another value. To solve it, left, right, middle, and what is that magical left? The invisible E. So left, right, middle is going to say E to the third equals 6x plus 1 squared. Review, what are we solving for? X, right? X is our variable, we're solving for X. So what step would you like to take to work to get X by itself? Okay, since it's 6x plus 1 to the second power, we have to square root. If we square root one side, square root the other side. So, the square root of 6x plus 1 squared is 6x plus 1. And actually, I think some of you guys tried to solve this, didn't you? Now that I think about it. We had enough time that some of you tried to solve it. Because I remember there's a calculator, like you guys were struggling to get the second answer. Now, what about the square root of e to the third? There's a couple different ways we can talk about this, so I'm kind of curious what your thoughts are. Cyrus?
Can we just move it into like the actual decimal? So like do e to the third and then just square that decimal, or do we have to keep e?
So we could talk decimal here. The only thing with decimal is you'll want to leave that full decimal on your calculator, not just clear it off and use a rounded decimal. I always encourage a full decimal here. Just to be careful there. So that would be one option. You could kind of go decimal. Eli? Okay. If you remember your powers, and if we're going to go decimal, I mean, to carry it down, you could write the decimal, or you could write square root of e to the third. What is the index here? This is an index of 2. And so you can also say it's e to the 3/2 if you want. And I don't know if that's a little bit easier to enter on the calculator. It might be. So you could say e to the 3/2. And even when I write the next step, what do you know about 3/2? 3/2 is the same as 1.5, 1.5. So you can even make that an exponent of 1.5 to work with. There's lots of different ways we could work with this, okay? Now, before I move on to the next step, there's one key thing that I won't say we've forgotten, but I haven't written down yet. We took a square root in an equation setting, so plus or minus. So whether you write it as plus or minus the square root of e to the third, plus or minus e to the 3/2, plus or minus e to the 1.5, plus or minus some crazy decimal, write it however you want there. Yes, Kendra?
I did plus or minus e times the square root of e.
That's equivalent.
Okay.
I think it's going to be harder to plug into your calculator, which is my concern.
I was able to plug it in.
Okay, if you've got it in the calculator, it works. I mean, it's equivalent, so. Okay, 6x plus 1. How do I continue solving for x? Okay, this is middle school steps, guys. If it's 6x plus 1, we subtract 1. Now, when I write this, I like to write -1 plus or minus e to the 3/2. I'm open to other ideas, I mean, you wouldn't have to. You could put plus or minus e to the 3/2 minus 1 afterwards. And what's the final official step? Divide by 6. So your x is -1 plus or minus e to the, I said I'd change that from 3/2, didn't I? What do we say was equivalent to 3/2? 1.5. All divided by 6. Now, grab the calculators, and let's see if we can get matching answers on our calculators. For me personally, it's not too bad to do on the calculator. I could really put this all in the calculator at once if I want to use parentheses around the top, but I'm going to enter the numerator, hit equals, and then I'll divide by 6. So I'm going to do -1 plus, let's see, where's my e on this calculator? My e is the second function of ln, so e to the 1.5. Now, if you didn't do 1.5, you could just easily type 3 divided by 2 in there also. I get that. Take that number. Okay. I thought my recording had froze up, but it didn't. Okay, I'm going to take that number and I'm going to divide by 6. So one of my possible answers is 0.580. So x is approximately 0.580. How do I get the other possible answer now? Repeat the process, but this time it's going to be -1 minus second e to the 1.5. And then I'm going to after I hit equals there, I'm going to divide by 6. -0.913. 6 tells the 3 to go up, so -0.914. Ooh, not going to let me forget, huh? Last step when you're working with square roots, logs, anything that could restrict whatever values you use. Go back and check to the very original problem, is what I always say. And our concern is always negatives, right? Because the inside of a log cannot be negative. If you look at the original problem, what happens when we put this negative in? Is the original function squared? No, we did that in step 1. So officially, if the original function is not squared, we can't use that squared. 6 times a number that is almost -1 is going to be a negative number that when I add 1 to it, I'm still going to be in the negatives, and your calculator could confirm that. So in this particular problem, only the positive value will work. Okay, so again, just watch out. Negative answers need to kind of give you a red flag today, and you need to stop and think about them and not just assume that everything's going to work. Okay. Okay, so that was a little bit of review from Friday, using these log equations and trying to solve log equations. So when there was one log in the equation, how do we solve it? That was left, right, middle. Now, bless you. We've got to solve the other type of equation. And the other type of equation when solving, they're not log equations. They're exponential equations. Okay. 4e to the 2x plus 2 equals 16. Our job is to eventually somehow solve for x. Thoughts on where to start? My suggestion is going to be that we work to get the x term by itself, which that means in this case we're working to get the e to the 2x by itself. Okay, so we can't really get x by itself in this, the first set of steps, but work to get whatever base raised to the power of x by itself. So if we're working to get e to the 2x by itself, what's got to be step 1? Yeah, if it's 4e to the 2x plus 2, subtract 2. If I subtract 2 on the left, subtract 2 on the right, 4e to the 2x is going to be equal to 16 minus 2 is 14. What would be the next step you'd see? Okay, if I want e to the 2x by itself, so I don't want any coefficients left out there, we're going to divide by 4. If I divide the left by 4, divide the right by 4. So on the left, 4e to the 2x divided by 4 becomes e to the 2x. On the right, 14 divided by 4. Okay. You could leave it as 14 fourths. You could reduce it to 7 halves. You could say 3.5. Based on the fact that I'm going to be using my calculator here to solve this, we're fine with going 3.5. I mean, this is a calculator. When you've got an Ethernet in there, this is a calculator problem. Okay. Now, we've got a weekend thrown in the mix here, but we did this back in lesson 7.5. You have e to the 2x equals 3.5. That x is in the power, right? Officially, if I go back to lesson 7.5, I'm going to grab my gold paper, and I'm going to say, can these bases be made the same? That's the step I would officially start with, is can these bases be made the same? Well, I have an e and a 3.5. My gold paper works with whole numbers, right? It doesn't work with e's. It doesn't work with decimals. Okay. So that's officially where I would start. What was plan B back in lesson 7.5 when we couldn't make the bases the same? We took the log of both sides. Now, back in that lesson, we did log log because we could just use our calculator then, right? Now, I'm not going to encourage log log this time because there is a e in the problem. I would always encourage you to take the natural log of both sides. And you'll see why as we go through here. So we're going to take the log of both sides, but we're going to use natural log. So I'm going to say the natural log of e to the 2x equals the natural log of 3.5. Now, let's look at what's going to make life nice here. What is the base of natural log again? E. I don't care about the right side. I'm not going to write it on the right side. I care about the left side. Natural log base e of e to the 2x. I know a lot of times we would use the power property and bring that 2x out front, but I'm not going to here. You could, I guess, doesn't matter, but what do you notice? Or what do you remember, I should say?
Something to itself.
If the power in the log, it's going to be 2x1.
Does this sound familiar?
Because the e's are the same. So
Okay. If the base of the log and the inside of the log are the same, then this expression is equal to whatever your exponent is. What is my exponent here? 2x. So my equation becomes 2x equals natural log of 3.5. Now, if you pulled that 2x out front and then you did your division stuff we did back with regular logs, that would work as well. To me, this is just a little easier, though. And how do I solve for x? Divide by 2. Now, what is it I'm dividing by 2? The natural log of 3.5, yes? It's not 3.5 I'm dividing by 2. It's natural log of 3.5. So I'm going to do ln 3.5. I'm going to end my parentheses on my calculator, and then I'm going to divide by 2. See, it's round to nearest thousandth, 3 decimal places, so 0.626. 3 tells that 6 to stay. How was it?
Yeah.
You like it better than the last problem? Okay.
Yeah.
I can respect that. Okay. Let's try at least 1 or 2 more of these and look at the word problem. And we'll see where we're at on time here. So B, if you would. Show me you know what you're doing. E to the x minus 2 equals 12. What is step 1? Okay, ultimately we're trying to solve for x.
In this one, I will use the power property and move the x minus 2 out of the e.
You can't use the power property until there's a log involved.
Oh, yeah.
The power property, easy mistake to make. I expected to hear that answer, so I wanted to hear that answer. We can't use the power property till there's a log there. And right now we don't have a log. Allie? Could we go ahead and take the natural log? I mean, last time our job was we had to get e to the power by itself first, right? So it took a couple of steps. This time, you have e to the power by itself. Yeah, it's e to the power of x minus 2, but that's by itself, so we can jump right into take the natural log of both sides. So natural log of e to the x minus 2 equals natural log of 12. What would be best to do here? What do you know about that left side? Yeah. When it's natural log of e, it's just going to be equal, natural log of e is 1. If you type natural log of e on your calculator, you're going to get 1. And so that's why we can just go ahead and make this x minus 2 equals natural log of 12. What do I do to solve this? If it's x minus 2, add 2. So x is the natural log of 12, and then add 2. Does it matter how you do that in your calculator? Definitely does. Do natural log of 12, either hit enter or you must close your parentheses, and then you can do plus 2. 4.484. 9 tells the 4 to make it. $4.485. Okay. C. 2e to the negative x equals 20. Okay, to get that e to the negative x by itself, divide by 2. So if I divide by 2, e to the negative x is equal to 10. What's the step I take here? Should have a lot of people telling me this. Natural log. So natural log of e to the negative x equals natural log of 10. Some of you may have skipped over that step, I don't know. What's the natural log of e to the negative x? Since those bases are the same, it's just negative x. So if negative x equals natural log of 10, how do I solve for x? Okay, she says divide by negative 1. Is that what everyone says? Okay. The other option is you could say multiply by negative 1. I was kind of guessing most of you said divide by negative 1, so either multiply or divide by negative 1. So basically, it's natural log of 10 and the opposite sign. Natural log of 10 on my calculator is 2.303. 2.303. If I divide that by negative 1, it's going to become negative 2.303. Okay. I almost feel like we could open it. We'll do D real quick. It won't take us long. Step 1. Tell me. Okay, we're trying to get e to the power by itself. Subtract 5. What do we get when we subtract 5? E to the 3x plus 1 equals 10. Now what? Okay, we've got e to some power by itself. So take the natural log. So natural log of e to the 3x plus 1 equals, don't forget, natural log of 10. How do I solve for x? Oh, wait. In my brain, I was already there. What do we know about the natural log of e to the 3x plus 1? It's just 3x plus 1, right? So 3x plus 1 equals natural log of 10. We're going to need to what? Subtract 1. So 3x is natural log of 10 minus 1, and then we're going to divide by 3. Again, as always, know how to use that calculator. Natural log of 10 in my parentheses. Minus 1. I'm going to go ahead and hit equals because I didn't use other parentheses. Divide by 3. 434 is in 0.434. Okay. real quick. We'll just do A down here. Example 4. A spacecraft can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers per second. The formula for a rocket's maximum velocity v in kilometers per second is v equals negative 0.0098 t plus c natural log of r. The booster rocket fires for t seconds and the velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket filled with fuel to its mass without fuel is r. Suppose a certain rocket has a mass ratio of 25, a firing time of 100 seconds, and an exhaust velocity of 2.8 kilometers per second. Can the spacecraft attain a stable orbit 300 kilometers above Earth?
That's a lot of information.
It is, isn't it?
A lot of work.
But I did step 1. What was step 1? Read it. So you've at least heard bits and pieces of the problem, right? And now it's, it's dissecting it all. Did you notice something important in there? It gave us an equation. Okay, so let's grab that equation. V equals negative 0.0098 t plus c natural log of r. Now, what the question is, can a spacecraft maintain a stable orbit 300 kilometers above Earth? What is true in order to obtain a stable orbit? Go back and reread.
Used to be 300 kilometers.
Okay. We can attain a stable orbit 300 kilometers above Earth if it reaches a velocity of 7.7 kilometers. What does this equation find? The velocity. So what do we need? We need this velocity to be 7.7 or bigger. So, did they give us some information? Okay. A certain rocket has a mass ratio of 25. What variable does the mass ratio go in? R, because it says in the previous sentence, the ratio of the mass of the rocket filled with fuel to its mass without fuel is R. So we know 25 is R. A firing time of 100 seconds. Only makes sense that would be time, right? And an exhaust velocity of 2.8 kilometers per second. What did it say the exhaust velocity is? Exhaust velocity is c kilometers per second. So this is c. And it talked about the velocities in kilometers per second. I think everything on this problem is kilometers and seconds, isn't it, though? So we should be okay there. Fill your equation in. V equals negative 0.0098 times t, which is 100, plus c, 2.8, times the natural log of r, which is 25. You can do the two individual bits and then add them together. My calculator would let me type that all in. Which, I don't know. We could use our brains here. What does multiplying a decimal by 100 do? Moves the decimal where? 2 places to the right. So really this is just going to be negative 0.98. So I really could just do negative 0.98. However, if you missed that confidence and you just did negative 0.0098 times 100 and then plus 2.8 times natural log of 25. Notice I just typed it all in and it works as well.
I think this should be
So check and see you get the same answer. I have approximately 8.03. And this velocity would be kilometers per second. Okay. Is that the answer to my question? Technically, no. My question is a yes or no question. Can the spacecraft attain a stable orbit 300 kilometers above Earth? Yes or no? Yes, because?
Because it's larger than 7.7.
Okay, because the velocity is greater than 7.7. So I'm going to say yes. Velocity is greater than 7.7 kilometers per second. Okay. If you're motivated and you want to try the second part, you can. The second part basically just gives you different information. Mass ratio, exhaust velocity, and firing time are all different. Same question, though. So, if you do the next one and you get a velocity of approximately 5.39, what are you going to know? Does not reach that 7.7, so it would not attain a stable orbit. Okay, you've got about 10 minutes. Your homework that is due tomorrow is lesson 7-6 in Math Excel.
Since I was gone, can I take a picture of Friday's notes?
Yes, hold on a second.
Okay.